This is Mr. Beck Does Your Homework. This is question number 3. It says a solid sphere has a radius of 0.86 meters and a mass of 170 kilograms, a solid sphere. How much work is required to get the sphere rolling with an angular speed of 32 radians per second on a horizontal surface? Assume the sphere starts from rest and rolls without slipping. So I want to do work, and what I know from my previous studies is that what work does is that work changes the amount of energy I have. So in other words, I have to figure out how much energy it has when it is rolling at 32 radians per second. So that energy is all going to be kinetic energy. So the energy I'm going to have, so the amount of work I need is going to be the energy I'm going to have is going to be my rotational kinetic energy, because it'll be rotating at that point, plus my translational kinetic energy, because it'll be moving at that point. So my rotational kinetic energy is going to be 1/2 of I times omega squared. And to that, I'm going to add my 1/2 mv squared. So I need to add those two together in order to get my total. Now, the I of a sphere happens to be 2/5 of mr squared. So 2/5 mr squared. And I'm given the m and the r of that sphere. So now let me plug some of this in. So I've got my work, I'm going to continue up here, equals 1/2 of 2/5 of mr squared times omega squared plus 1/2 mv squared. You can solve from here because you know, the one thing you don't have here is you've got a r squared omega squared here, and you've got a velocity here. And you're looking for a angular velocity here in radians per second. So the way you figure that out is using your knowledge that your angular velocity times your radius is going to equal your linear velocity, or your linear velocity divided by your radius is going to equal your angular velocity. So here, where you have a v in 1/2 mv squared, you can replace that v with omega r and take the omega r and make that omega squared r squared. So now you've got an equation in which you're looking for this and you know all of this.